distributive property is something we can utilize to multiply numbers in a real convenient way. Sometimes it's rather difficult for some folks to grasp until you've actually seen it a couple times. So I'm going to review several examples. This is going to be my examples again, not what the book has, but I'm going to do, let's just say, multiplying 6 times 48. If you're anything like me, you can't do that in your head quickly. So you're going to grab your calculator. But if you do not have your calculator, you can actually break this up into 40 plus 8. Okay? 40 plus 8. That being said, if you multiply the 40 and the 8 by 6, you then will actually have 6 times 48. And I'm pretty sure you guys can do 6 times 40 in your head and 6 times 8 in your head. The sum of both of the products then get added together. You end up with 288. That is the whole purpose of the distributive property, is to make you able to easily multiply things that you need to multiply without grabbing a calculator or a pencil and a pen. This is also useful for fractions and decimals as well. So I'm going to show you another example that'll be fraction or decimals. So if I tell you 4 multiplied by 3 1/4, I can pull out a calculator, or I can break 3 1/4 into 3 plus 1/4, right? And if I multiply the 4 by each piece separately, 4 times 3 is 12. That's the first piece. And 4 times 1/4 is 1. The big mistake people make is they'll only multiply by one of the pieces, instead of remembering that both of those pieces has to be multiplied by the number in question. Fractions, say 6 multiplied by 4 1/3. What are we going to turn 4 1/3 into? Yeah, that's what I would do. All of that getting multiplied by the 6. Six times 4 is 24. 1/3 of 6 is 2. And you should end up with a 26. Now, something to keep in mind is that the convenience of this relies on the fact that 1/3 of 6 is a whole number, just like 1/4 of 4 is a whole number. Okay, sometimes it's not quite as convenient as you'd like it to be, but when it works that way, break it up. If it doesn't work that way, forget it. Like, say, take this example. 9 times 4 1/2. So 9 multiplied by 4 plus 1/2. I know you all know that half of 9 is 4.5, but it's not nearly as convenient as these other ones that are easy, right? 9 times 4, 9 times 1/2. Okay, so that isn't quite as convenient. It works, obviously, but it's not nearly as easy peasy convenient like the other ones. When variables are added to this, it works as well. So I'm going to go ahead and switch to example 2. For these, you broke them apart because it was easier, right? But for variables, you don't have a choice. You can't combine them and make it easier or make it doable. You cannot make this. This is not 7y. This isn't anything other than y plus 7. These are two different types of things. That's a variable, that's a constant. You can't put them together. So we have to multiply them separately. So this is an example when you have variables where you have no other choice, whereas here you did have a choice. 6y positive 42. Okay, you did not have any other options there. Even if the number comes after the parentheses item, you can still perform that multiplication. So something like this, for example, 6x plus 9y multiplied by 2. So here we've got that number in front. Here it's in back. It doesn't change anything. The technique doesn't change. Remember, matter or order is not important in multiplication. You can do 2 in front and multiply it, or you can do the 2 in back and multiply it. That results in 18y. The other results in a positive 12x. Sign is important here, positive and negative. I'll never put a sign in the first piece where it's positive because it's understood. But recognize that if this were a negative 2, it would be negative 18y and negative 12x. Okay, so be very, very careful with what signs you're given. Whether or not you're adding or subtracting this is all very doable. How about this? This will be 4 times 3z minus 2. What's that going to end up being? Lee, you have any idea? Good. Super. You guys okay on this so far? All right. Just a couple more things. And the gray box illustrates all of that for you if you want to look over the gray boxes there. But example 3, I'm going to show you here next. Here's example 3. 23 times 26 added to 77 times 26. Notice that both the 23 and the 77 are being multiplied by 26. They are both sharing the factor 26. So if I factor that 26 out like that and place these two numbers and add them together, lucky for us, we're going to come up with something that we could do in our head. Look for locations where you can do that because it does make your math easier. Look at that. So far, so good? Those aren't quite as obvious as some of these other issues, but know that that is something you can do. Here's another one like example 3. 3.6 multiplied by 25 minus 1.6 multiplied by 25. Both of these items are being multiplied by what factor? 25, yep. If I pull that 25 out and then place 3.6 minus 1.6, I will now have a convenient way to multiply this out. 25 times 2. Does that look about right? So look out for that. If you have shared factors, lump them together. And then take the other factors, connect them with whatever operator they have. This is subtraction, that was addition. And then perform the math, and you're done with it. We're going all the way up to number 56 evens today.